Question 7 in the gantry starts off with a bit about kinetic energy. So let's just see what happens when we use our standard kinetic energy equation here. The mass of the container is 7080 kilograms, and the velocity at the bottom of the swing is 1,8 meters per second. We've got to square that, and so we end up with a certain amount of mechanical energy that this container has as it starts the swing. We now need to work out whether it's going to swing too far and whether we're going to have to close operations. So if you think of the swing of this thing, it swings like that to the side. It's on a rope that's 13 meters long, so each of these lengths is 13. But what we're going to do now is we're going to calculate what this height is here. Okay, and when we've calculated that height, we can proceed to work out this angle here. That's an attempt at theta, a very pathetic one. Don't laugh, Joshua. That will give us then our permissible swing. So let's take the potential energy which is going to equal mgh at the top. It's going to be the same amount, 11469,6, and so therefore h is going to be 11469,6 divided by the mass and gravitational acceleration, 7080 times 9,8, and so that gives us 0,165 meters. Okay, that's meant to be a 6. So that tells us that this height here is 0,165 meters. So if we want to work out x now, and the whole thing is 13, so x is going to be 13 minus 0,165, and x is going to equal 12,835 meters. Okay. Now look carefully at this 90-degree triangle here. Cos of theta, that's a much better theta, equals 12,835, which is the adjacent side, divided by the hypotenuse, 13. Go away. So therefore, theta, when we take out our calculators and do shift cos, theta comes out to be 9,14 degrees. Gantry can operate. Why it continues is because that angle there is smaller than the permissible angle that's allowed. Now finally, we need to just work out the power here. We've got time. Oh, interesting. And we've got a distance. So if we can just work out the force, then we'll be able to work it out. And the word is steadily here. Okay, this is really weird. But steadily is the key word there. And so what it means, if it's steady, it means that F net is 0. Okay? And if you think back to what we've done before, that means that the force of the gantry, that's the force with which the gantry is holding it up, plus the gravitational acceleration is 0. And so therefore, the F of the gantry is going to equal 7080. It's going to equal mg, it's going to equal minus fg basically, which is minus 7080 times minus 9,8, 69,384 newtons. So now we can just work out power. power. Power is work done over time taken. Work is equal to force times distance, not T, sorry, not impulse, but work here. And so it's that same 69384 times the distance that it gets lowered, which is 16 meters, divided by the time, 47 seconds, and you get a total of 23,620 watts, which is a mean machine for those of us who like big toys.